Let's solve some problems on Doppler effect. You can find these questions on the in the textbook, and the question number is given next before the question here. So let's see what is told, what is given to us in the question. The car approaches with a speed of 24 meters per second. There is a stationary train that sounds its horn. What is the frequency heard by the driver? So let's draw the situation. I have a car that is moving at 24 meters per second. It is moving approaches, so it's moving towards the train and the train station. This train is stationary, so its speed is 0 meters per second, but it has a horn with a frequency of 166 hertz. So my observer's velocity is 24 meters per second, and my source's velocity is 0 meters per second. My source's frequency is 166 meters per second. Oh, excuse me. Hertz. And the observer's frequency, the frequency heard by the observer is unknown. Doppler effect tells us that the frequency of the source and the observer are related when the two objects are moving towards each other, are related by this formula. Where v is the sound of speed of sound, 343 meters per second. So solving this equation for our situation here, we get 1 plus 24 divided by 343, and this becomes 1 minus 0. So this is 166 times 1 plus 24 by 343. Quickly calculating this, I get 4 divided by 343. I get 177.62 hertz. Now this makes sense because when an object is moving closer to the source, when the observer is moving closer to the source, the frequency heard by the observer will always be higher than the frequency of the source itself. So that's our answer. Moving on to the second question. This is question 52 from the textbook. We are given that a train on one track moves in the same direction as a second track on an adjacent track. So again, we have two trains, and the train on one track moves in the same direction. So the speed of both these objects is in the same direction. So this the first train, which is ahead of the second train. So this is train number 1 and this is train number 2. Ahead of the second train moves with a speed of 36.8 meters per second. Blows a horn whose frequency is 124 hertz. If the frequency heard on the second train is 135 hertz, what is its speed? So the given things are here. Firstly, speed of sound is 343 meters per second. My observer in this case is train number 2. So observer is unknown. Frequency heard by the observer is 135 hertz. The frequency, the speed of the source is 36.8 meters per second, and the frequency of the source is 124 hertz. All right. So again, looking at the equation we have by Doppler effect, we can see that, let's look at it this way. Because the observer is moving towards the source, we will have a positive in the numerator. Because the source is moving away from the observer, we will have a positive. To explain this further, the Doppler effect tells us that if the observer is moving towards the source, you use a positive. If it's moving away from the source, you use a negative in the numerator. Similarly, if the source is moving towards the observer, you use a negative in the denominator. And if the source is moving away from the observer, you use a positive in the denominator. So that's the situation, that's the relationship. So for our situation, we use this formula. So we have the source's frequency. We also have the observer's frequency, the frequency heard by the observer. We do not know the value of u naught. We know the value of v. We know the value of us, which is the source's speed. Right. So simplifying this equation, we will just move 124 to the other side. So this becomes 343 plus u naught divided by 343 plus 36.8. So solving, let's move things around for u naught. Becomes 343 plus 36.8 multiplied by 135 divided by 124 minus 343. So solving this equation, the value I get is 70.49